Hello.
Hello. Hi.
Hi, are you able to hear me?
Yeah, I can hear you fine.
Okay, cool. Hi. So great. Nice to meet you virtually. This
Uh,
is about a 45 minutes session for Google style standard interview, which is algorithm interview.
hmm
Is that what you are expecting?
Sorry, what is that?
Oh, so this is a standard Google style algorithm interview. Is that what you are expecting?
Yeah, I'm looking for on-site level question.
Of course, absolutely.
Okay.
So
Yeah.
usually at about the give or take 5 minutes are set aside for intro and stuff, and out of the 40 minutes, usually in Google there would be two or three questions. The first one is expected to be implemented fully.
Okay.
The rest of ones depends on how much time you have in hand. At
Okay.
least some discussions and depend on where. So, I today I have two questions. The first one is pretty straightforward as such. The second one would be in the next level. So
Okay.
I again expect that the first one I am expecting a full implementation, and the second one we can, if there is no time, we can discuss.
Okay.
And
All right. Sounds good.
I mean, since this is a practice interview, I'm telling you all these. And usually, of course, when you go in on site, they won't say any of these.
Okay.
Um, but before that, just anonymously, let's introduce ourselves. I'll start first. So, I'm a L6 software engineer in Google, and I work in Google Cloud at this moment. And I have in past worked in mostly in distributed systems and artificial intelligence. So currently, I'm working in distributed systems.
Okay.
Tell me a couple of things about yourself, what you're looking for. Are you target, since this is a Google specialty interview, I'm assuming that you are probably planning to appear for Google or something like
Yeah.
that.
Yeah. So I work for Facebook, and
Okay,
I'm a compiler engineer. I write compilers. I
okay,
write C++ compilers. I have
okay,
about 5 years experience. And yeah, as you said, I have an upcoming Google interview in about 5 weeks.
okay, nice. So, and you're targeting which level? Is it like L4, L5?
L5. Yeah.
Okay, nice. Okay, cool. So let's begin then. So I'll just copy paste the question here, and then we'll go
Okay.
from.
Do you mind I go to C++?
No, C++ is fine. That's fine.
Okay, I'll go to C++.
Yeah, yeah, that's fine. So again, usually, I mean, you can run and compile here.
Mm-hmm.
Usually, in the Google interview, you don't need to run, but it's a choice. I mean, here you're free to do it.
Okay.
So, I'll just what I'll do is let me just copy paste the question here.
Okay.
Right.
So, given a binary tree, return all route to leaf path. Okay.
Mhm.
So I'm thinking I can go from the top and visit and basically DFS all the way to the list. While I do this, I can keep basically a path of basically numbers, right? That I
Sure.
visited.
Sure. You
So
can keep the numbers or it's the
you
integer
copy the
value, so sure you can keep
yeah.
those.
Okay. Okay. So just so can I write the code?
Yeah, of course. Please go ahead.
Okay. So I'll have a global variable result dfs root, and I will need to keep basically as I go through the tree, I need to keep what I have seen. So
Sure.
visited. So I'll give it visited. Then after that I'll just do it to result. So basically this I have a void dfs tree node root string visited. So if not root, I basically reach the, it's not, I have to be careful because I need to check for, if not root, I don't do anything.
Sure.
If it is a leaf node, I basically concatenate visited dot basically plus equals to string root value and result push back visited and return. Otherwise, I do basically a DFS on my. Okay, so if this is I'm a leaf node, so here I'm not a leaf node. Basically, what I do is I do a visited plus equals root, also plus the arrow sign. Okay, and then I basically, okay, so string temp equals visited, and then DFS. I don't need this. I basically visited DFS root and visited. So this will root, basically I go to the left tree, DFS root, I go to the right tree, and then so somewhere I need to basically, so I add this, and after I'm gone, so after I visited this, I need to basically take back my result. So visited equals temp. What I can do is so because here we are processing the current node, right? We add a current node to it, and then we basically recurse down the left and right tree. But then after we are done with the current node, before we return to our parent, we need to basically take back what was originally, because so that our parent can visit other nodes. And I check root is now, we don't do anything. If root is a leaf node, I basically add the final value and then I push it back. And then I also need to basically so string. So basically I need to but why don't I do this? I can just do basically plus 2 string root value here. So I don't need to basically change visited. Right. But here visited is changed, so I need to get it back. So I cannot do anything here because a leaf node has a left node and a right node. So if we do anything here and don't handle leaf node, then we would be pushing the same path twice.
Sure, that's fine.
Yeah.
So okay, so is that the solution, or do you want to run or test it?
I could, but the problem is I need to construct a tree.
Okay, so sure. So here's the thing. So in this case, looks like if you why don't we do one thing? Why don't we take one of these the example tree?
Sure. So basically we have something here.
Dry run it.
Yeah. So we dry run it. So here we visit is empty. We have a root coming in, which is 1, right? So right here we have basically a 1. Basically do something like this, right? The first level. Then we go to DFS onto the left side. So 2 is not a leaf node, so it doesn't do anything. So we then add basically 2 to it, right? Then we DFS on the left side, which doesn't do anything, right? Because it doesn't do anything. Then we DFS onto the right side. The right side is 5, and it happens to turn out to be a leaf node, so we add 5 to it, and we return. We don't DFS anymore.
Sure.
But when we return here, because we add this visited remains unchanged, so we get this path already. Have this path already. But visited here is this, right? It's 1, 2. Okay, 1, 2, 2 is exhausted. So we go all the way up to 1. So we come back to 1. Then
sure.
we basically DFS onto the right side, which happens to be a leaf node. Then we push it in, we return, and then we return because the left and right child of 1 has been handled, and the visited actually happens to be after we return the visited is empty string. And we basically get this path as well here. It's 1, 1, 3.
Okay, so one thing is that looks like in the implementation you have, you might end up getting paths like instead of that, so 1 to 5 is fine, but instead of 1 to 3, you are probably going to get 2, 5, or maybe then it goes to there, 2, 3, something like that.
Could I don't think so. Because why do you? Because I first take 1 into the string, right? Then I go to 2. Then I get 1 to 5. Okay. When I unwind this level, this 2 level, I go all the way. I basically my line 67. You will reassign to basically temp. Basically temp here is going to be 1 point.
Right, but the thing is, here you're changing visited to one arrow 2, right?
Yeah.
Then when it goes to 2, it will change to 1 arrow 2, correct?
Yes.
On the left side.
Yeah.
And you have also used a reference here.
Yeah. Yeah. But I reassigned line 67.
You are right, but you have reassigned after visiting both left and right.
Yes. Yes.
Is that correct?
Yeah.
I mean, after you have DFS on the left side, I mean, if you look at the tree, it will go from 1 to 2 left side, right, from the root, 1 to 2 to 5. When it comes to 5, yes, you have not modified visited.
Yeah, I didn't modify it.
1 and 2, you modified the visited, correct?
Yeah, that's right.
So then it will be 1 arrow 2, but you are not, and then it will come back to 1. But when it comes back to 1, what do you think this visited contains from the left side of the tree?
When it comes back to 1, it contains just one arrow.
Who removes the 2?
The 2 gets popped out because of the assignment on the 2 level. So when you add the level 2, you before you add 2 to it, you keep the visited. But at a point you begin to unwind the 2 level, you reassign it.
Okay, let's say one more thing. Let's say in here on the.
Why don't we build a tree and let's see.
Yeah, so let's do one more thing. Let me modify this example once more, right?
Okay.
So let's say I have one more here, like 4 or something.
Okay.
Right. So in that case, so it will come 1 to 2 to 4, right? So 1 to 2 to 4 would be here. Then it pops back up from the left side, and this will contain 1 to 2.
When you reach 4, you will contain 1 to 2. Yeah.
Then it will go to 5.
You will contain 1 to 2 as well.
Okay. So someone is resetting this. Okay, fine then. Sure.
Yeah, yeah. So you will. But this assignment here it worries me a little bit because it's a copy of the string. So maybe we could basically record basically the integer size equals basically we stated size, and then we basically we stated erase, we stated begin plus basically size, and we stated and let me see what it works. So if you were originally 1 and you add 2 to it, okay, so it's 3. So you come back. Start with let me see. Yeah, I think that will work. Yeah. Okay.
So what was the problem with the assignment?
Because it's a copy of the string. It's not.
Oh, you're trying to optimize it. Okay, sure.
Yeah, I try to optimize it. Yeah.
Okay, cool. So how do you test this?
I think I'll build a tree. So
Sure.
like a tree of this one, and I will also test things like null pointer. I will also test the things like it's only root. And what else? And I will test something with basically a leaf node. It's not a leaf node like this thing. Basically, 2 is not a leaf node, but it doesn't have the left children.
Sure.
So yeah, that's some of the cases I can think of.
Sure. So maybe also think of stress testing it. For example, you can give really large tree. Also, the ones these are all, for example, good test cases that we have provided. Maybe you can also test with some bad cases. For example, malformed tree, there are disjoint trees, or maybe what about, someone said it is a binary tree, someone has given it, trinary tree or something. So those are all sort of negative testing also you can try out.
Okay.
So also, for example, another different kind of testing is here it says integer, right? But maybe someone has given the content of the tree is different. Although in this case, once the tree is formed, it is hard to do. But also maybe there are some in C++. There can be garbage pointers, and it can lead to crash and all the stuff. So this code is fine for as an implementation, this is fine. But for in a real life, for example, maybe the tree data structure is corrupted, so we can have some exception handling and so on and so forth.
Okay.
Maybe with checking. Yeah, that would be cool.
Yeah.
So good. That's nice. So let's move on to the next question. Okay. So let me just point in this here in this section. So let's see. So let's say this one, right? So what happens is that, I mean, our task in hand is, for example, we don't know it's any sort of language, right? It's not English, but it is just using the English alphabets. And our task is given a series. Let's say it gives a portion of the dictionary of this new language, which happens to use the English letters. What we would like to find out is that what are the alphabet ordering. So, for example, if someone gave A, B, C, D, we know that A, B, C, D is in order, so we give the ordering. So here is a bunch of words which are lexicographically sorted, which means in a dictionary order. And from here, the output it gives that this is the order of the alphabets in this language. So a couple of more examples are as follows. So in the example two, if you see, as you can see, z, there's only z and x. So in this case, output is z. And example three is invalid case where it says that x is followed by z, but again z is followed by x, so it cannot happen.
Okay.
So it's a,
I see. I see.
yeah.
So first of all, do all these things are they lowercase letters?
Yeah, let's assume that these are all lowercase letters, and if there are multiple solutions, any one is fine.
Okay. Let me think. Okay. So I'm thinking this is something like because if you look at here, right, W definitely goes before E. So in the final alphabet, W definitely goes before E. Similarly, E definitely goes before R. Right?
Sure. Yeah.
So we can derive this relationship, but then this so on the second one, R we can't really on the second one, because we can only tell the difference of a letter if their previous letters are the same. Because if we can already tell their previous letters apart, then the meaning of this letter, this column of letter is really, we don't really know, right?
Can you say that once more?
So in the first column, W definitely goes before E and E goes before R, right?
Correct.
But if we look at the second column,
yeah,
we can't really tell whether the relationship between R and T, because R could be small, could go before T, or it could go after T, because the W before it already dictates the ordering of this of the WRT, WRF, ER, and ETT, right? So this column here, we can't really derive the relationship of R and T, but if their previous letters are the same, then we can tell, right?
Yes.
Okay. So I'm thinking with this sort of so basically, if their previous letters are not the same, then we cannot tell. If the previous letters are the same, then we can tell their relationship. And with this relationship, I'm thinking we can build a graph. Then we can do a topological sort on the graph to get the ordering.
Sure. So how would you go about it?
So so there are two parts to the solution. I think one is basically analyzing the word list, trying to extract the relationships between the letters. The second part, once you extract the relationship, you can basically add the relationship into the graph. And once you do that, you can sort of do it. Then the second part is doing a topological sort.
Sure. Sounds good. So would you like to implement or?
No, I still have some. So if they are the same.
So for example, let's go over an example. Let's go over the first example, and maybe describe how would you build the graph.
So I look at the first column. W goes before E. So I basically, in my graph, I would have a add parent, add order, like W,
So
then W is the parent.
let's write it here. So W goes for
yeah.
E. Okay. This is what
So I would do something like add order. So this I'll give it a W and E. Basically that indicates W goes before E.
Sure.
So in my graph. So I'll just do this. So then I will also add order E R. Then that would indicate E goes before R, right?
Sure.
So that's that. So then the second column is a little bit tricky. Second column, okay. So the second column, we need to check. Yeah, but then how do you break them into groups? Right. So I need to break them into groups.
Yes.
Based on basically the first column. Let me think. W goes before. One way is I do a brute force scan. See whether their previous is the same. So that's it's basically a brute force scan, breaking them into groups. But that's not really optimal. Right. I could do that, but
so these are already sorted, right?
yeah.
So for example, when you are doing the first column, maybe while extracting the relationship of the first column, can we break them up into groups?
We could. I'm still thinking. Yeah. So when we visit the first column, we know. Okay. So the second column group is this. Yeah. I guess we could. Yeah. So the second column group is this, and when we do this, yeah. So basically, I think the start of the group is basically initially 0, right? So every time I go down, I locate whether I'm equal to the previous one or not. If I'm equal to the previous one, I keep expanding on the. So yeah, I basically keep expanding on the. Let me see. I start with 0. So initially I only have one group, right?
Yes.
Initially I only have one group. This is going to be 0 to 4, right? So then I will construct the next column groups. So next column groups. So what this is when I first I start with basically 0, and 0 is equal to 0. So I don't break it into groups. 1 is equal to the 0. I don't really let's say okay, 0 is equal to 0. I don't break into group. 1 is equal to 0. I don't break into groups. So then I have 2 is not equal to 0. So then what I do is I break 0 to 1 into group, and now my starting point is basically 1, right? So 1 is equal to 1, so I don't break them into groups. 2 is equal to 1, I don't break it. Then 3, then basically I break it here. Then I do a 3.
Why 0? Why are we breaking 1 and 2?
Because they are both E, and sorry, it's not 1. Sorry, it's not 1 and 2. It's it's 2 and 3.
Right. Yeah. Okay.
Yeah. Sorry. Yeah. And then I have 4, and it's going to be with itself. Right. Okay. Then when I reach a second column, I locate the group list. And I iterate on them. and then I keep dividing into other groups. And it's also possible this one doesn't really have us. If it doesn't have one, if it doesn't have one, then I just if it doesn't have one, let me think. Then I skip it. It doesn't matter. Yeah, because you could have this, and this you could have something like this. F and X would still be able to tell the relationship, and they are still the. I mean, if we change this to ER.
Yes, correct.
This will still be able to tell the relationship. I only break generally new groups when I say different basically a different character on the second column in this case. Then I break them into groups.
Yep.
So basically, I have this algorithm to break into groups, and every time I increment a column, and if in a group a column doesn't exist, then I don't do anything. I don't break further groups. I just continue. Yeah.
Sure. So once you construct a graph like this, how do you detect an error? I mean, let's say, I mean, under what condition would you not be able to define the output relationship?
If we cannot do a topological sort of the graph, basically we have a cycle in the graph. Yeah.
Sure. Like the last example, that is one. If there is a cycle, we cannot. Is there any other condition where we cannot really define?
Let's say if there is a cycle, we definitely cannot do it. Let's say input Vx. Well, I think it's possible to have multiple solutions, but I guess we discussed about that, right?
Yeah, so if there is multiple solution, any one is fine.
Yeah,
but what is there other than the cycle? Is there any other way or condition where we may not have a deterministic solution?
What if a letter a letter exists in the words, but we don't have an order for it?
Correct.
What does that mean? That means we can put it anywhere. What does that consider? No solution.
Yeah, so which cannot define the alphabet. So if the if the input is something like A, B, C, D, B, C, D, then we know it is between A and B, but we don't know how C and D are related, right?
Yeah. So yeah, basically this
incomplete set. So we need more input to analyze.
Okay. Yeah.
Cool.
Yeah,
cool.
That's right.
So that's pretty much the question I had. I mean, now we can kind of discuss about. You can write a pseudocode if you want. I think that your solution is correct. Or if you want
I'll write a code to try to break them into groups. How about that?
Sure. I mean, we don't have much time, so maybe write pseudocode instead of the full code.
Okay, so I'll just void add order.
Maybe what you can try doing is try to break up the code in a modular fashion, so that
so basically
groups as you form, you can kind of reuse the same functions over and over.
Yeah. So basically I'll just process column and integer column, and I have a vector of integer groups, and I also have the basically the vector. So this basically this will break them into groups, and also I want to basically have a vector. I'll have current group. I'll have a vector of int next groups. So this will break them into groups and basically also compute the next groups. And then I just do a bool tuple sort. So basically, it will take a basically a vector of nodes graph. So you will do a topological sort, and basically return true if possible, false otherwise. And you will also basically you will do a pair of and you will give me a string, and the string is really just a string. First is the sorted output, and basically I will also define something like a node. What a node does is node. So a node is basically a public function. A node, what it does is I have the character in the node. Then I basically have integer parent count, right? So basically every time I only need to keep track of the parent count, right? So this node has some basically let me see. I have order function. I'm sorry, yeah.
Yeah, so the graph is a vector of node pointers. So then how do you know the child or the next one?
We need to know the child. Yeah, we need to know the child. So it's going to be basically we are going to basically have a vector of character and children. So yeah. Basically this would add ordering. What it does is you would basically get a node pointer. Basically this would you would graph parent.
Do you want to do that vector of character or vector of node pointer?
I will do a vector of node pointer.
Sure.
So graph is going to be p minus 0, and node pointer child equals graph p minus c minus a. And basically what I do is basically okay, so the children parent count plus and the parent children pushback C. Okay, yeah, something like this. And of course you will have to give it to the graph. So this graph can be pre-constructed. Yeah. And then so basically every time we process a column, we do basically for integer start equals so first of all, for vector int g in current groups. Okay. For integer start equals g0, integer start small equals g1 plus start. Okay, so we do that, and what do we do? Okay, if start basically okay, start is we need to be careful how to do this. Okay, so if Okay. So if let's say dictionary start column, I think this needs to be -1. If dictionary start column is basically okay, this is a little bit tricky to figure out. So basically, I need to check whether I need to build a relationship of okay. So okay.
So essentially, what we have to do is for that group, we go over which index we are browsing, right?
Yeah.
So
yeah.
for the original group, the first group, we are browsing the 0th position, and then we also need to specify each group which index we are browsing, and then we are going to browse those index. We are just going over left to right, and whenever that changes, if the current one is not equal to next one, then we add a relationship.
Yeah. So basically,
observe that in each group, just like you are preserving the indices, we need to preserve. I mean, like the words. We need to preserve which index we are browsing.
Yeah. I am preserving the indices. Yeah. So basically, I need to basically. So here, what do I do? So I locate if I am equal to the. So let's say if the current one is equal to the next one. If the current one is equal to the next one, then I don't. So first of all, I don't change the group. But I also don't add any order. Okay. Otherwise, I need if basically dictionary basically let's say start column equal dictionary start +1 column. Then I need to fix up the condition as well here. Then we continue.
Equal to should be less than, so.
Yeah. Otherwise, basically add ordering. Basically. So you add ordering, and also we need to basically group equals basically G0. We start at G0, and we basically end with start, and we just basically next group.
Yes. Yes, and we also need to take care of the last group.
Yeah. So yeah, the last group is a little bit tricky as well. Okay, so let's do this, and so the last group and we need to push in the last group as well. So basically, the last group is going to be so we did this, and we are going to basically next group push basically let's say. Oh, okay. So if you never, and it's going to basically the last group is going to be so where's the last group going to?
Last group would be something like wherever you was your last index chart, right? I mean, so it has to be
Yeah. So So I'll do this begin group. So
Yeah,
this is going
something.
to be basically G0, right? And basically.
And then here you have to be the start class one needs to be assigned to that. Yep.
Okay, so then after we basically break out this, and eventually we are going to, okay, so we are going to begin group. Next group is going to, we need to break out this one, and hold on.
So the last group would be essentially your begin group to G1.
Yeah. So yeah, so I'm still thinking where to edit. And it's going to be ending. I'm not sure this is but then if we do this, we need to skip. So when you come in, you get this, and you keep doing it. And when you reach something, when you reach basically this is no longer equal, then we basically stop right here, and the begin group gets adjusted here. And after let's say if we just have one group, and we have one group here, we break it into two groups. Basically what happens is, the first group will start. Yeah, I think that will add a last group to it, and it's going to be inactive also. And that's then we can basically keep doing this until we basically then we can keep calling process column, and if current groups empty, return. And there are something like if column equal to size.
Okay, yeah, that's fine. I think look at the conditions. That's fine. So will this be dict size, the last group you're adding? Will this be the dict size -1, or would it be the the G1? Because we are iterating over.
Oh, okay. It would be
So this is for just outside of this, right? So then, which means it falls off here, and it should be this and G1, and then it will move to the next group.
Okay. So yeah, so here would be
This will just be end index of that group, because we are further splitting the current group, right? Okay, yeah, that's fine. Okay, cool. I think that's fine. So a few things is that you have done great. So that's fine. One thing is that I have noticed that you are using a lot of the pass by reference, and in Google what I have seen is that we don't use we only use constant reference.
We only use
So the reference is only passed using constant, so we cannot really modify it.
Okay.
So
Okay.
what,
So we
for
only.
here one, you have also used the visited here, right? And we don't use that, so people might because it's just a style what Google uses. So whenever we need to
Mhm.
modify, you can pass a pointer instead of a reference. And references
Which
are all.
line? Which
For
line?
example, in the earlier solution when we did the string visited
Oh, okay.
in,
Okay.
so it is fine in general. I mean, it's absolutely valid C++. It's just that Google as a company, they tend to use constant references, and if there is
Okay.
if something is modified, it needs to pass by a pointer.
Okay. So how should I fix this? I pass it by so this particular example, do I just pass the string or
No, you pass the pointer to the string.
a pointer to the string? So I do this.
Yes.
You mean? Okay. Oh, okay. So you said the reference is only constant, and
Yeah.
pointers are okay. Okay.
Yeah. That's keep in mind, but I don't think it's a big deal. It's just a
I see.
Google
I
style.
see. I see. I see. I see. I see.
Yeah, I think other
Cool.
than that, you have done pretty well. We didn't have time to discuss the complexity, but it's pretty straightforward as such. So
Mhm.
should be all right. We have done really good for the second question. So congratulations on that.
Yeah.
So I just had that one piece of feedback, nothing else. Um, if you have any other questions, and also so two things actually. So one is the style thing, and another is the testing. So maybe you want to think when the testing comes, think out of the box that what portions can really go wrong. Maybe stress more on the negative testing since you are. So give a pathological case, give a normal case, give null pointer, single node, multiple nodes, full tree, skewed tree, all those things, and then also move on to the negative testing for all of those.
Okay. I see. I
Yeah.
see. I see. How important are the testing? Let's say in the tree example, how important, how much emphasis do you guys put on testing?
So as such, if the interviewer, I mean, in general, you can ask for something. Sometimes interviewer might ask you to how to test it, and they would look for how comprehensively you are testing.
Okay. Okay. But let's say if I got the question correct, if I got the algorithm correct, but my testing
Hmm.
is really lacking, is that a possibility? Could that be a reason to basically to fail the interview?
I mean, so okay, so your motivation would be to get as strong signal as possible, right? So you don't want to cut corners. So what would happen is that interviewer might say that okay, he's solving the problems really well, strong coding, but maybe testing can be better. Now
Okay.
if everybody gives a strong yes versus someone says maybe not, so and I mean if you can see, let's say, let's assume that out of the 5 interviews one of those are not that didn't go that well, right? Let's take the case. Now let's say that is a design interview or some behavioral interview didn't go that well, but out of the other 4 interviews or other 3 coding interviews you have done really good in coding an algorithm, and now your choice is either you can go soft on the testing or really do good testing there. So
Okay.
I think your side, don't leave anything open because you can do the testing, right? So just think about
Okay.
it, think through. I mean, think you put yourself in the shoes of the user. Assume
Mhm.
that you don't know the code and you are trying to break it. What all testing would you
Mhm.
do, right? Once you think from
Mhm.
that side, that will give you the perspective. And but to answer your question, that no, that in particular interviewer will probably not reject you for that interview,
Mhm.
but they will also, you would not be hitting it out of the park because they would be looking for a holistic view. So they would say, yeah,
Mhm.
maybe testing can. You don't want that, right? I mean, you want them to say that, yeah, he's great.
Mhm.
So whatever you can, make it complete. Don't door open for doubt.
I see. I see. I see. I see. Okay.
So great, but if you are not, but then you are, if there is a comparison that hey, out of four, one interviewer says maybe not, Then if others are very strong, then that will get superseded, right?
Okay. I see.
Yeah.
So I also heard, is this sort of the scale your people use in Google?
Sort of the scale.
Yeah, the basically, I'm on line 51. Line 51.
Line 50. Yeah. Oh, strong,
So
no hire, no. Yes, this is the scale. You're right.
so how would you rate this particular interview?
I would something between hire and strong hire.
Okay. All right.
So
Okay.
for
I just
yeah,
want to know where the bar is, sort of. What the
yeah.
expectation?
So I'd probably not give strong hire, because if you a strong hire is everything is perfect. A hire is
Okay.
very good, perfect score, right? Very good score. A strong hire, so that's why maybe I would give higher and then verbally say maybe if the testings were perfect, didn't need some amount of prompting, he was all through awesome, then it would be a strong hire.
Okay. I see.
What was your expectation? Does it match with your expectation?
I would say I was thinking of maybe lean hair and hair, maybe more towards the hair, but it seems
Yeah.
higher than I expected. But
So because I was impressed with the second one. I mean, even if you did not do the coding, your algorithm, and since within this limited time you are able to say the algorithm and you coded up the pseudocode pretty well, so that's why
Okay.
I definitely gave it a higher, and I would say put in a good word for that. So the initial testing miss is okay. I mean, so it's definitely a higher. So follow with that.
Also, the second question, I think a lot of things I broke it down by abstraction reasonably well, right? So the add order I just basically abstracted away, right? So
Yeah.
so
No, this is good. This is modular code because you are reusing the same function. That is what the ask was. Also,
Okay.
if you remember, I mean, we discussed a lot since this is a practice interview. We discussed a lot as you were thinking through. In real life, interviewer is not going to discuss with you. And remember that for each such discussion, they would probably say that don't take don't give the opportunity to the interviewer to say those. I mean, whatever I said today at the end is proactive, but to listen to the interviewer, and whenever they say something which it might be some hint, and if you take the hint and run with it, that is a plus point. So they would
I
say
see.
that okay, this kid knows how to take a hint and go with it.
Okay. I see.
Yeah, I think it's the same as Facebook. I'm sure you also conduct interview in Facebook, right?
Sorry?
I'm assuming you also are an interviewer in Facebook, right? You also conduct
Yeah.
interview.
I do some interviews there, but usually in Facebook we don't give very difficult questions. And actually, if you give a very difficult question, recruiter will find you and ask you why you gave a difficult question.
Okay. Yeah.
Yeah.
So yeah,
But Google
one
usually
is,
give a slightly. Yeah, sorry, go ahead.
yeah, sorry, go ahead.
No, you go ahead. I'm fine. Yeah.
Oh, no. I was just saying Google has the Google question style is scaling in. So usually they would start from, easy to medium question, the first one just for warm up, and then they will progressively go into more and more difficult question. If you can solve faster, it will give more questions. That's the style typically. So sorry, you were saying something.
Yeah. So I was about to say about the same thing as what you just said, but I have another question. So
Yeah.
I heard they ask a lot of follow-up questions, right? Sometimes.
Sometimes they do, yes. So for example, here I also asked one follow-up question, like other than the loop in the DAG, where else can this fail, right?
Okay. I see.
So next time probably we would also discuss more follow-up questions like the scale. So Google loves to discuss scale. For instance, if your graph is too big, how do you solve? And the last problem would be very abstract in a sense. I mean, what if your algorithm doesn't, the amount of the graph doesn't even fit in memory? How would you solve it? Those kind of things.
Okay.
So once you reach I mean, you can be pretty sure that you have S prime. So
I see. Yeah,
yeah,
I see a lot of Google questions. They ask what if the dictionary is too large? How do you do it? What if something is
correct.
too large? How do you do it? Right.
Yeah, that is what I was mentioning. That in this case, if the graph is too large, how do you do it? Those kind of things. For every problem, think about how can you scale it.
I see. Okay, I see. But just out of curiosity, how would you do it if the graph is too large? Because I don't have a distributed system background, but you do. How would you do it? I just want to.
Yeah, so you have to essentially divide and conquer, right? I mean, just like the MapReduce
Mhm.
works. So you have to
Mhm.
partition the graph and read and do partial and save it back, and then combine the results successively.
I see. So usually this sort of thing is divide and conquer. It's just how do you divide and how do you combine, right? How do you merge eventually, right?
Yeah,
So
yeah,
it's also case by case basis. Different questions are different, but the underlying principle is about the same, right?
exactly.
Okay. I see.
Alright,
Okay.
I think we had a lovely chat, and all the
Yeah.
best for your interview.
Thank you. Yeah.
All right, cool. Thanks, man.
Yeah. Thank you. Yeah.
Okay.
Okay. That will be it. Thank you. Bye.
Bye bye.